and go from slideshow. There, I can find it. Current slide. All right. Oops. Probably need to turn on the projector. Okay. I think I made all these announcements last time, but in case any of you were here that weren't here last time. Number one, sad news, especially for anyone who has a Friday class. Any of you have Friday classes? Oh, too bad. No Friday classes this week. Okay? The colleges close this Friday to honor or celebrate Veterans Day. Actually, Veterans Day is on Saturday, but the college is closing on Friday to celebrate that. So, don't try coming to the college to get some business taken care of or see an advisor or anybody else, because it will be closed. The whole campus is closed. Okay? So I won't be at office hours 7:45 to 11:45 on Friday in the Birmingham campus. Okay? Now, number two. This is long range, but I really encourage any of you that, especially if you're thinking of going into math, a little bit higher math, and you're interested in math, the math team is beginning practices for, is it Brianna? Brianna, sorry. Okay, for next year's competitions. And so if any of you are interested in that, it's fun. It's low pressure, but it also is a big help when you come to your higher level math courses. You will already be ahead of the game when you get in those courses. You'll just, I think you'll find it really is a very, very useful thing. And did I say it's fun? It is, believe it or not. Everyone I've worked with on it seems to really enjoy it. Okay. And then the other thing is, I think I said this before, but just to say it again, I hope all of you are registered to vote in the state of Alabama. If you happen to live elsewhere, take care of that. But if you are registered to vote, there is a very important election coming up December 12th. Please plan to go vote on that. Before you come to school, after you leave school, sometime make time to go by and vote. Only one race is that special Senate election, so typically there's extraordinarily low turnout for that, so your vote counts even more. So please don't forget to vote. Get your family to vote. Get your friends to vote. The people from church, anywhere around, neighbors, get them to vote, because it's an incredibly important election. My wife, I think I told you this before, my wife did some crunching of the numbers. She works with numbers a lot. She's an epidemiologist at UAB, and she, looking at the people who voted. Okay, I know you're in here. There is, right? Yeah. All right. Looking at the people who voted in the primaries for this runoff, for this election, the top vote getter got 8% of the registered voters in the state of Alabama. That's nowhere close to democracy. I mean, that is a small special interest controlling who's going to be our senator, for years. Okay, so please don't let them, and they don't want you to vote, really. They want to control a small number of people, controlling as much as possible. Please get out there and vote and get as many people to the polls as you can. All right, and I just had a question coming in. Why is the U.S. flag at half-mast today? Is it because of the shooting in Texas, or was there something else that has occurred? Does anyone know? I just saw it was at half-mast, and I just called the police I went by the police office just to make sure it was supposed to be, and he said, yeah, it's supposed to be. Anyone know? That was just my own interest. All right. Example 8 in the text. Goodness gracious. All right. On a blueprint for a construction, any questions on anything before we go into example 8? Okay? On a blueprint for a construction job, 1.5 inches, whoops, let me get my pen activated. It won't activate, there it goes. All right. 1.5 inches, okay, represents 15 feet, corresponds to 15 feet on a blueprint, you know, laying out the building, okay? If two columns are 2 inches apart, okay? Find the number of feet between the columns. What is the number of feet between the columns? Okay? How would you do that problem? Any ideas? Thoughts? No thoughts at all this morning. Too early, huh? Okay, you will ultimately. How do you set up the problem? Second, a proportion. Excellent. How does the proportion go? Second? I heard something, but I couldn't make out what it was. Okay. We set up two ratios. One is 1.5 inches. I'm going to put the units in just for is to 15 feet. As, that's equal sign, what? 2 inches is to, and you what do you call it? X. Okay. So we let X equal that thing. Okay. And here is Cole, got it? Andrea and Jay, right? Okay. Anyone else come in since the called roll? Okay. There it is. We have a proportion. This, anytime you see something like this, that just smacks of being a ratio. 1.5 inches represents 15 feet. You know, so therefore, that sets up one ratio. The other one says 2 inches. The columns are 2 inches apart. How many feet? So inches to feet is inches to feet. Make sure that your units match. That's why I put them in here. Okay? Now that we've got it set up, how do we solve this? You've got a proportion, what do you do with it? Cross multiply. And what do you mean by that? What do you mean by that? Yeah, absolutely. 1.5 x is equal to 30. Okay. Now, I don't know if Melva's, I think she was thinking in the right direction, but I think a better way to do this is write this as what? 1.5. Say again? 1.5. Okay, that's one way you could do it. If you want to go to fractions, you certainly could do that. Okay? So let's do that. 1.5. You're going to need a calculator then. The other way, I think you can get by without a calculator, but let's do, well, won't need a calculator. 1.5x is equal to 30. And then what do we do? Divide both sides by 1.5. Okay, now if you remember how to divide fractions, the 1.5s go out over here on the left. Here we have to move your decimal one place to the left in the to the right in the denominator, so you have to move your decimal one place to the right in the numerator as well. So now you have 15 into 30. Does anyone know what that would be? I mean into 300. 20. That would be 20 feet. Does that make sense? If 1.5 inches is 15 feet, 2 inches is a little bit longer than 1.5 inches, so 20 feet is just a little bit longer than 15. Yes, that makes perfect sense. Okay? Doesn't guarantee you the right answer, but it sure makes you feel warm and fuzzy about it, right? Now, the other way that you could have done this, and I'm guessing maybe the book did, but yeah, I think they did, is they changed the 1.5 to, any ideas? Okay, make it 3/2 x is equal to 30, right? Okay, now how do you solve that? Say again? You may have said it right, I just don't hear well. Make it 1, is that what you said? Oh, okay, you could do that if you wanted to. That's perfectly a legal move. And, Natalie? Huh? Kanisha, okay. There you are, okay. All right, good deal. Anyone else come in since the called roll? Okay? What will you do from here? There's a couple ways you can go. What would you like to do? Okay, yeah. Yeah, what we're trying to do is isolate the x. Chuck, right? Okay. There you are. Okay, we're trying to isolate the x. How do we go about doing that? Okay, divide by 3/2, which is the same as multiplying by 2/3. Dividing by 3/2 is the same as multiplying by its reciprocal. So multiply by 2/3. That makes the left-hand side 1, right? The coefficient. We'll multiply this by 2/3. Okay? The 3's go out, the 2's go out. You're left with x, isolated, just what you wanted. Over here, 3 will go into 30 how many times? 10 times, and 10 times 2 is 20 feet. So either way you do it will be fine. The one other way I like to do this, though I went by what y'all said, when you had this, I'd multiply both sides by 2, and that makes 3x equal 60, then divide by 3, and you got x equals 20. So lots of ways to get there as long as all the steps are right, okay? Take right steps. Any questions on that? Okay. The key is to get it out of a mixed number, either into decimal, like Seth suggested, or into an improper fraction, like whoever else suggested that, I believe. Say that one more time. Yes. You see, the reason you multiply by 2/3 is to make this a 1. So yeah. And you multiply this side by 2/3 as well, and this divided away, 3 will go into 30 10 times. Okay. Good deal. Good questions too. The distance between the two columns, 20 feet. And one more example before we end the day. All right. Let's erase all the ink. That's one I was trying to hit. All right, here's example 9. A sum of, oh, y'all aren't interested in money, are you? Okay, a sum of $750 is to be divided between two people okay, in a ratio of 2 to 3. They've already given you the ratio, 2 to 3. Okay? How much does each person receive? Okay. Now, most of the time when I have a problem like this, I initially focus on what's the question? What is the question here? How much does each person receive? So actually it sounds like we got two answers here, right? You got, I don't know how you want to call it, person A and person B, poor person, rich person. I don't know how you want to say this, but you got two people. You need to have two answers. How much does each person receive? All right? Now, you can maybe either set up two different variables and try to narrow that down to one, or start with just one variable and see if you can figure out how to work it with just one variable. Works out the same way. How would you like to proceed? We need to name a variable. And tell me what it is. What you want the variable to be. Second? N? Okay. All right. And there is this, right? Yeah. All right. So let N. Now, which you want that to be? Now, how do you want to designate these people? The poor person who gets 2, or the rich person who gets 3, or do you want to designate a person A, person B? I don't care how you want to designate it.
3.
Huh?
3.
3. The one that gets 3. Let N equal the amount the 3 person gets. Okay? So that's going to answer the question for the one who's on the 3 side. Okay. Now, is there anything else that this problem suggests to you? And I would take it to suggest to you that you look at that very first sentence. A sum of $750 is to be divided. So if N is going to go to person 3, how much is person 2 going to get? Okay. I wish we had $750 together and we'd figure this out. Okay. All right. How much would person 2 get then? Person 3 gets N, and the sum of $750 is there. How much does person 2 get? Give me some thoughts. Second? It says sum. What does sum suggest? Adding. You're adding these two together to get 750. So if you know how much one is, how do you get the other one? How do you undo addition? Subtraction. So does that give you a hint on what the second person gets? And here's Tara. So then, that's it, $750 minus N. If the number 3 person gets N dollars, then all that poor old number 2 gets is 750 minus N. Whatever is left over when number 3 gets his money, or her money, or whatever, okay, is equal to the amount the 2 person gets. Does that make sense? Okay. Are we ready to try to do a proportion? Okay, as I mentioned to you, the problem I already told you, the ratio. What is that ratio? 2 to 3. So 2 is to 3 as, that's equal to, how much does the 2 person get? Read the line above it. 750 minus N over, how much does the 3 person get? N. There it is, folks. What do we do from that? Cross multiplying, what does that tell us? 2n is equal to 3 times 750 minus n. So let's figure out what that is first. Multiply that out. That'll be a 0, that'll be a 5, 15, that'll be a 22, right? Everybody see it? Okay. Minus what? 3n. Okay. So I'm going to take this to the top and rewrite it as 2n is equal to 2250 minus 3n. There's my equation. Okay? What do you do to solve it? Add 3n to both sides. You got to get those n's together on the same side, so let's add 3n to both sides. And what do you get then? 5n is equal to 2,250. Then divide both sides by 5, and that gives you n is equal to, looks like a 4, looks like a 5, 0, 450 bucks. Does that make sense? Sound reasonable? You're dividing 5 into 2250. 5 and 22 will go 4 times. 4 times 5 is 20. Carry a 2. 2. Bring down the 5. Subtract and get a 2. 5 will go to 25 5 times. 5 will go to 0 0 times. $450. And what's that? That's the amount the rich person gets. The number 3 person. Okay? So how much you reckon number 2 gets? Because it asks for how much does each person receive? 250? 300. Yes. Okay, that sounds better. Okay. Then this is 250 to the 3 person, and 750 minus n would equal $300 to the 2 person. Okay? And certainly that works. Now, to check it, well, let's just do. So that's see the ratio of 2 to 3. So let's put the 30 on top, 45 on the bottom. Okay, well, okay. The 300 on top and the 450 on the bottom. And I can divide out 10 right there. And let's see. 15 will go into 30 twice. 15 will go into 45 3 times. Yes, that works. Make sense? You see how it works. Use what the problem tells you. Figure out what the deal. What we're looking for, how much each person receives. Okay? Well, pick one up. Y'all chose the 3 person. That's fine. Then how much does the 2 person get? Whatever the difference in 750 and what the 3 person got. Okay, the difference there. And then you can set up your ratio 2 to 3 as to make sure you keep them right. The 2 person gets this, the 3 person gets that. Make sure the ratios are the same. And then when you do your cross multiplication, there your answer pops out to you. Does that make sense? And the book even got it right. Look at that. They actually chose D to be the money that the 1 person receives, and 750 minus D represents the amount the other person receives. And then it didn't matter which you put where. D wound up being the 2 person, and 750 minus D was the 3 person, the way they set it up, and it works. Okay. There is a concept quiz, bottom of page 221, top of page 222, okay? Bottom of 221 is true-false. You won't see many of those on a quiz or test or anything, but still it's a good idea to read through that and figure out what the answer is. Actually, only 1 through 3 are true false. Sorry about that. Let's look at number 4 and do number 4 in class. Identify the following equations as a proportion or not a proportion. Okay, does everybody know? Not all of you have books, do you? So what I'm going to do is erase all the ink here, and let's do number 4 here. Is 2x over x plus 1 plus x equal 7 over x plus 1. Is that a proportion? JT's here, so that should mean something. Okay? Is that a proportion? Yay or nay? Was that a yes? Okay? It would have been if that wasn't there. But that is there. Proportion has to be A over B equals C over D. Not A over B plus something equals C over D. That is not a proportion. Now you can make it into a proportion by making a common denominator here of x plus 1 and then figuring out what goes on top over x plus 1. And then if you get it in that form, then that could be a proportion. It's not as written. Okay? Let's do B. Is this one. X minus 8 over 2x plus 5 equal to 7 over 9. Is that a proportion? Yes, it is. One ratio equals another ratio. Nothing added, nothing subtracted. One ratio equals another ratio. That is a proportion. How about C? 5 plus 2x over x plus 6, if that's equal to x minus 3 over x plus 4. Would that be a proportion as written? No, because that 5's out there messing things up. Now if you put 5, get least common denominator here of x plus 6, that would be 5x plus 30. Add that to that, would be 7x plus 30 over x plus 6. That would then be a proportion. But as it's written now, that is not a proportion. Okay? And I'll say you can do concept quiz question number 5 on your own. It's I don't know. It may not be too. I was going to say it looks like it's going to take too long to do. Let's try it. Okay? But y'all don't have your book. That's the only thing. I don't want to have to write this. It says select all the equations that could represent the following problem. John bought the 3 bottles of energy drink. I'm abbreviating like crazy, for $5.07. Okay. If the price remains the same, okay, what will 8 bottles of drink cost? Okay, there's the question. Okay. I would say you set that up as a proportion. What would that be? Or can you? Yeah. Can you? Do it. How do you do it? All right, you can set it that way. 3 is to 8 as 507 is to x. Very good. That is a perfectly good way to set this up. 3 bottles is to 8 bottles, as the cost of 3 bottles is the cost of 8 bottles. That's exactly what it is. What will the 8 bottles cost? That's what the X is. Perfect. Can anyone set it up as another proportion? 3 over 507. 3 bottles is to 507 as 8 is to X. And that sets up perfectly too. Guess what happens, folks? Let's do our cross multiplying. 3X is equal to 5 times X. Guess here, 3X is still equal to 8 times 5. Yeah. That sets up perfectly well either way. So their answer here is that 3 is to 507 as A is wrong. 507 is to 8 as X is to 3. Wrong. Okay. 3 is to 8 as 507 is to X. Yes, C works. And 507 is to 3 as X is to 8. There's another way you can set it up. Perfectly fine. So actually, C and D both work as well as the one we did there. And you could have even done 8 is to 3 as X is to 507. That works too. Okay? So there's always at least 4 ways to set up a proportion. All right. In problems 6 through 10, match the equation with the solution set. Okay, you'll have to work those out, so I'll let you do that. Homework exercises then. Any of the odds 1 through 43. There's a whole passel of those, but you have probably already been working on them diligently, so you won't have that many more to do. And then any of the odds 45 through 55. Okay? Really some good problems there. Work on those. Now 4.7 is another great section, but we just don't have time for it. And I was trying to rack my brain to see if I had seen any problems like any of these on a final before, and I don't think I have. So that's why I'm going to skip this section, even though it's a good section, and if you're really interested in these kinds of problems, keep working, because these will work out well here. But you're not responsible for it. Now, other things that you might want to do. Now, remember, okay, your test is Monday, okay, which means I need those quizzes in, folks. A few people turn them in. I do have all of those graded that were turned in. I don't have them on Blackboard yet. I hope that today, if I don't get a bunch of interruptions in my office hours today, I hope to be able to get that caught up today, okay? Sorry that it's taken so long, but it seems like, well, I had my car die on me. I had to get a new car. I had to get a rental car. It seems like everything that could go wrong last week did. So I got way behind in doing this. And when I was on Birmingham campus, I had a stack of papers about that high to grade. And I had so many, my boss wasn't in, so everybody that came in, I had to help them. So it really, I didn't get as much done last Friday as I intended to. Got some done over the weekend, but we had a pretty busy weekend too. So hopefully today I'll have 2 fairly uninterrupted hours of office hours. Hopefully I can get that caught up. Okay, so with the test being Monday, what can you bring with you? Formula and equation sheet. Now in the chapter 4 summary on pages 232, 233, 234, 235, 236, 237, there's a summary here. And I'm not saying this needs to be on your sheet, but if you can find anything on here that would be helpful to you, anything that deals with sections 4.1 through 4.6, like that first objective, 4.1, objective 1 and 2, 4.2, objectives 1 and 2, 4.2, 3 and 4, 4.2, 5, 4.3, objectives 1 and 2, 4.4, objective 1, 4.4, objective 2, 4.5, objective 1, 4.5. So everything through the bottom of page 235, on those 4 pages there of the summary, if that's helpful to you, use it. Okay? Now, for 236, it looks like everything, no. Page 236 deals with 4.7, but when you get to 237, they go back to 4.6. at the top of the page anyway. So you might want to look at the top of the page there too. Another thing that you might find helpful to study for the test is a review problem set. And again, the odd numbers have answers in the back, so any of the odds 1 through 5 would be fine. Either 7 or 9 would be good. Any of the odds 11 through 23 would be good. 25 would be good. 27 or 29 or both would be good. Any of the odds 31 to 41 would be good. Okay, and then the problems, okay, let me back off from that a minute. I would say, well, any of those would be good, but a few of those are a little more complicated, like the 4.7 problems. If you can't do, say, 39, 41, don't sweat it too badly, even maybe 37, okay? But if you can do it, fantastic, okay? Then on the problems there, 43, 45, I know those are good ones. Some of the others might be 4.7 type problems. So I'll let you decide if you want to do any more of those. Okay? And then there's a Chapter 4 test. Now, if I'm not mistaken, I think that all the test things, all their problems are in the back. Let me see. Review. No, I take it back. On the review problems, all the ones there, not just the odds. All the odds are there. I mean, all the exercises, 1 through. So you can do all those review problems. And the Chapter 4 test, all of those answers are there. Here are the ones I would suggest that you do. Any of 1 through 4, any of 5 through 16, no, 5 through 13, any of 14 through 16, any of 17 to 20, I know you can do, and I think you can do 21 as well. I believe you can probably even do 22, but if those get too hairy for you, don't sweat them too bad. I know you can do 23, 24 and 25 are from 4.7. If you can do them, go for it. All right. That finishes Chapter 4. Any questions on Chapter 4? Now, you don't have to stick to just those summaries. Anything from the sections you can write down on your formula and equation sheet. Anything you have trouble remembering, or the processes, anything you want to write on that piece of paper, you can. Okay? You can write poems. I don't care. I mean, whatever you want to write. All right. Any questions? So let me end this, and let's move on to Chapter 5. All right. Okay. All right, Chapter 5 is dealing with exponents and radicals. We've dealt with exponents forever, it seems like. We're going to get a little bit deeper into that, some of the rules and things about adding, subtracting, multiplying, dividing, all that kind of stuff. And we're getting into radicals. We touched on radicals when we did some of the Chapter 6 stuff. Now we're going to delve into them. And some of that you'll remember from Chapter 6 when I went over those quickly. Now we'll go into them in a little more detail. So we're going to start in 5.1 using integers as exponents. Later we'll have rational numbers as exponents, okay? But right now we're going to limit ourselves to integers as exponents. We're going to simplify numerical expressions that do have integral exponents. We will simplify algebraic expressions that have, okay, these are numerical expressions with integral exponent, algebraic expressions with it. In other words, these are just going to be numbers, these are going to have variables in them, okay? Number 3, we'll multiply and divide algebraic expressions that have integral exponents. Very similar to what we did when we multiplied and divided rational expressions, okay? These are easier when, believe it or not, the sums and differences. Then we'll simplify sums and differences of expressions involving integral exponents. So we're doing the same type of pattern that we did when we were dealing with rational expressions in chapter 4, we're doing with our exponential expressions in chapter 5. Okay? Thus far in the text, we have used only positive integers as exponents. 3, 7, 2, only positive exponents. Okay? From now on, we can let n be an integer. Later, we'll let it be even a rational number. So this expression, b to the n, that's a exponential expression. Okay? b is called the base, and n is called the exponent. So b is any real number. b can be any real number. Positive, negative, fractions, decimal, rational, irrational. It doesn't matter. Any real number. N, so far, is only going to be positive integers. Positive integers for now. Okay? Later we'll let negatives come in, then we'll let fractions come in. We'll do all sorts of things with them. But right now, when n is an integer, what b to the n means is take the base and multiply it n times. You knew that already, didn't you? X squared is x times x. 3 plus y cubed would be 3 plus y times 3 plus y times 3 plus y. That's what we mean by this. Whatever your base is, multiply. You can think of it this way, and this sometimes I do think of things in weird ways. When you started out adding and subtracting, right? Those are the first two operations you did, right? Way back, way back. And then, if you're adding the same number over and over and over again, it's so much easier to just multiply the number, right? If you're adding 7 4 times, 7 plus 7 plus 7 plus 7, and you have to sit down and add all those, it's so much easier to say 4 times 7 is 28. But in a sense, remember what I said about being a good mathematician? Just a tad lazy, right? Mathematicians say, oh, I'm tired of adding the same number over and over. Let's develop multiplication so it makes it easier, okay? Well, multiplying the same number over and over and over, we do that with an exponent. So we don't have to multiply 7 times 7 times 7 times 7. You just do 7 to the 4th power, if that's what it is, and plug it in your calculator and let it do the work for you, rather than having to punch in 7 times 7 times 7 times 7. Okay. That's the deal. It's just a shorthand to make things a little easier and quicker. Does the same thing, though. All right, so here's property 5.1. Properties for positive integral exponents. Okay? And slowly we will see that this property works even if they're negative integral exponents. And it works even if it's negative or positive, any kind of exponent. Okay? Real number exponent. Well, for now, let's leave it as rational exponent. We'll see. If m and n are positive integers for now, and a and b are any real numbers, those are going to be the bases, these are going to be the exponents. As long as b is not equal to 0 wherever it appears in the denominator, then here's the rules. B to the n times b to the m. What's b to the n? B to the n is nb. B to b to b to b to b to b. N times. B to the m is b to b to m times. Then you have a bunch of b's here. How many b's you got there? N plus m. So it's b to the n plus m. That's how you multiply same base, different exponents, keep the base, add the exponents. Okay? So here's something else exponents do for you. They take a multiplication problem and reduce it to an addition problem. As long as you have the same base, then you just add the exponents. All right? Now what if you had the base raised to a power, and you're going to raise that to a power? Well, that would be, let's keep a smaller number, like b squared. That's b times b. Now let's raise it to the 3rd power, right? That's b times b times b times b times b times b. How many b's you got? 3. Wait. b times b times b times b times b times b. 6. Okay? So b squared raised to the third power would be b to the 2 times 3. 6. Exactly. So again, you take the raising to a power, which is a higher level operation, and with the exponents, as long as it's the same base, keep the base, multiply the exponents. So you drop down a level. If you have adding and subtracting as the base, multiplying and division, slightly higher, exponents and roots, slightly higher, what your exponents do is drop them down one level. Now, what if you have a product of bases? AB to the nth power. Give me an n. Make up a number. 5. So that would be AB times AB times AB times AB times AB, right? To the 5th power, right? How many A's you got there? 5. How many B's? So that would be A to the n times B to the n. So if you're multiplying a product, raising that to a power, that is the product of the two powers. So the power of the product is the product of the powers. So everything, at least, seems like it makes pretty good sense, right? Let's see if it does. Oh, here's some more. What if you had A over B raised you n to be 5 again? Okay, so that would be A over B times A over B times A over B times A over B times A over B. How many A's you got? 5 divided by how many B's? 5 says A to the 5th over B to, or A over B. So the power of a quotient is the quotient of the powers. Okay? Pretty straightforward. Hopefully it's about what you would expect it to be, right? Okay? How about this one? B to the n. Now, we're going to keep n larger than m for now. Later we'll let this change. Okay? So n is some number larger than m. So give me an n, give me an m. N is? Well, 5 again? 5. Give me an n that's less than 5. An m that's less than 5. 2. Okay? So you have b times b times b times b times b, 5 of those, over b times b. What you got left? 2 of these cancel out. How many you got left? 3. So b to the n divided by b to the m is b to the n minus m. So now you change the division into a subtraction. As long as it's the same base, then subtract the exponents. Now this works when n is greater than m. Later we'll find out it works when it's equal to m or less than m. But right now it is. Okay. Now let's go to the equal to right now. Okay. I didn't know it was coming up this end. If n and m are the same, you want them both to be 5? If you had b times b times b times b times b over b times b times b times b times b, what you got? B to the 5th over b to the 5th is 1. Okay. 1. Okay. Remember, b can't be 0. You can't have 0 as a number. Okay. But what if n is actually less than m? So let's let this one, n be 2, and the m be 3. That would be b times b, or 5. B times b times b times b times b times b. 5 of those. Well, now you have 2 of them cancel out and divide away, 1 over b cubed. So what you do then is 1 over b to m minus n. If m is greater than n, then you have b's left over in the denominator. If n is greater than m, they're in the numerator. Right? Does that make sense? Okay. All right, a bunch of words now. We are now ready to extend the concept of an exponent to include the use of 0 and negative numbers as exponents. I just have a sinking suspicion they're skipping some examples, aren't they? No, they're not. I guess not. Okay. Goodness gracious. This isn't matching the book very well at all, is it? Okay. We'll get there. I mean, so far it's okay. We'll catch up with it and get back on track. So let's go. Now ready to extend the concept of exponent to include the use of 0 as an exponent. We're using only positive integers, and we'll even use negative integers as exponents. Okay? First, let's consider the use of 0 as an exponent. We want to use 0 in such a way that the previously listed properties continue to hold. So if we had b to the n times b to the m being b to the n plus m, right? Multiply two bases, same exponents, same base, different exponents, keep the base and add the exponents. Okay? If that's the whole, then x to the fourth times x to the 0 would be x to the 4 plus 0, right? And what's 4 plus 0? 4. So that'd be x to the fourth. Now look at this. If x to the fourth times something is equal to x to the fourth, what does that something better be? 1. So that suggests to you x to the 0 is indeed 1. In other words, x to the 0 acts like a 1 because x to the fourth times x to the 0 is equal to x to the fourth, so x to the 0 must be 1. Okay. Now, that seems a little bizarre. Any other number up here would be x squared, x fifth, x, whatever, that has x's in it. This doesn't, okay? Anything raised to the 0th power is 1. X plus 17 to the 0th power is 1, okay? 4 pi squared to the 0th power is 1, okay? Anything to the 0th power is 1, with one little exception. 0 to the 0th power is not defined, okay? You can't do 0 to the 0th power, but everything else you can. Anything to the 0th power is 1. X cubed minus 15x squared plus 4 to the 0th power is 1. Okay. Anything to the 0th power is 1, except, of course, you can't do 0 to the 0th power. All right, so this line of reasoning suggests the following definition. If b is a non-zero number, it can't be 0, remember, real number, any real number, pi, square root of 17, it doesn't matter, then that base to the 0th power is always 1. Always 1. Now, according to this definition, the following statements are also true. 5 to the 0th is 1. 3/11 to the 0th is. X cubed y4 to the 0th power is 1, okay? Negative 413 to the 0th power is 1, okay? N to the 0th power, whoops, is 1. And x, as long as x is at 0, oh wait, I'm sorry, that's for this one here, okay? This goes with this one, okay? X and y, and then n here can't be 0. Okay. So you get the idea. Anything to the 0th power is 1. Okay? We can use a similar line of reasoning to motivate the definition of the use of negative integers as exponents. So let's consider this example. X to the fourth times whatever x to the minus fourth is. What's our rule say? Now, they said for a positive exponent, but I told them they work for negatives as well. That would be b to the n times b to the m. This is x to the 4 times x to the minus 4. So b is like x, and n is like 4, and m is like negative 4. This says that's b to the n plus m, right? So, if you did that to this one, that'd be x to the 4 minus 4. What's 4 minus 4?
0.
0. Well, that says x to the fourth times x to the minus fourth is x to the 0th. And what is x to the 0th? 1. Okay. Oh, wait a minute here. That would mean that x to the minus fourth must be 1 over x to the fourth, right? So the only way you can get that to be 1 is this to be 1 over x to the fourth. So in other words, x to the fourth must be reciprocal of x to the fourth because the product is 1. Okay? So here's another rule. X to the minus 4 is equal to 1 over x to the 4. So anytime you have an exponent that's negative, you can send it downstairs and make it positive. Okay? Or if it's already downstairs as a negative exponent, you send it upstairs and that makes the exponent positive. The x stays the same, it's that the power changes sign. Okay? So here, this leads to another definition. Okay? N is any positive integer. Okay? And b is a non-zero real number, then b to the minus n, which would be a negative number, is 1 over b to the n. Okay? So anytime you have a negative exponent, a base is a negative exponent, send it downstairs. Or if it's already downstairs, send it upstairs, lose the minus sign. Okay? Make sense?
Yeah.
All right. So according to this definition, what would x to the minus 5 be? Say again? 1 over x to the 5th. Very good. What would be 2 to the minus 4th? 1 over what? 2 to the 4th. 2 to the 4th, right? What's 2 to the 4th? What's 2 to the 4th? 2 times 2 is 4, times 2 is 16. Okay, that would be 1 over 16. Very good. See how that works? If you have a negative exponent, send it downstairs and lose the minus sign. Don't lose the minus sign of the number, the base. That stays whatever it would be, but you would take the minus sign of the exponent.
So it go away or it don't go away?
What's that again?
The exponent.
The exponent is the little phrase.
Yeah, I'm saying it go away when you move it down.
If you move it downstairs, then it just becomes 2 to the 4th. Or if you're already downstairs with 2 to the minus 4th, move it upstairs and you lose the sign. When you cross that division line, change the sign of the exponent. Keep the base the same, but change the sign of the exponent. All right, it looks like, oh, here's some more things. What is 10 to the minus 2? 10 to the minus 2. A little louder? 1 over? 10 squared. Perfect. And what is 10 squared? 100. So that's 1 over 100. Perfect. Okay? Or if you wrote it as a decimal, that's 0.01. Okay? What is, how about this one? 3/4 to the minus 2. There's several ways you can go with this. It's what? 1 over 3/4 squared. That's one way to do it. And what is 3/4 squared? Square your 3. 9 over 16. So 1 over 9 over 16. But if you're dividing by a fractional form, invert and multiply, that'd be 69. Okay? Now this leads to something else, and I'm going to go in and introduce it to you now. If you have a fraction to a negative exponent, just flip the fraction and change the sign to the positive. You sent 1 upstairs and 1 downstairs, you made it positive, so that'd be 4/3 squared, which would be 6/9. So yeah, that's one. To me, that's easier to do it that way. What would this be? Whoa, now your negative exponent is downstairs. What do we do with it?
Take it up.
Take it up. So what would that be? A little louder? Yeah, the 2 stays 2. And what happens to x to the minus 3?
8. 6/30.
No, not over. It's already over x to the minus 3. Move the x upstairs.
Move the x2.
Yes. So they've moved this downstairs here, which is really weird. Just move it up there, okay? And that makes 2x cubed. That's exactly it. Without going through all that, okay?
So you move that whole number there.
Well, yeah, whatever is to the minus power goes upstairs, so it's 2x cubed. See? It just moves upstairs. It crosses the division line and loses the minus sign again. Right? Okay. Any questions? Okay. It can be verified, although it's beyond the scope of this text, that all of the parts in property 5.1 hold for all integers, not just positive integers. Okay? In fact, the following equality can replace the three separate statements in part 5. If you remember, we had one for n greater than m, one for n equal m, and one for n less than m. Now we can just say it one time and do it like this. B to the n over b to the m is b to the n minus m. That works for all of them. No matter who's bigger, who's smaller, works for all of them. If m's bigger, that means this is a negative number. If it's a negative number, move it downstairs. Okay? If n is larger, then it stays whatever that subtraction is. If they're the same, then that's equal to 1. Okay? Because n minus m would be 0. Okay? Works for all integers n and m. So you don't need three different conditions. One will do. Okay. Let's see if we can squeeze one more in. Let's restate property 5.1 as it holds for all integers and include at the right a name tag for easy reference. Okay? If m and n are integers, any integer, positive or negative, and a and b are real numbers, as long as you don't have a b in the denominator equals 0, then this. And this I think I've already said. The product of the same base, different exponents, keep the base, add the exponent. So this says the product of two bases, the product of two powers is the same base, sum of the powers. Okay? Okay. And this one, b to the n raised to the nth power. This is where the n or m, either one are positive or negative. You just multiply. Keep the base, multiply the exponent. That's the power of a power. Okay? And then the product, the power of a product is the product of the powers. Power of a product. Okay? I'd already said most of those. So there they are. Okay, I'm afraid. Oh, we're not quite out of time. Can we do one more slide? Oh, okay. We didn't quite get to example 1. Next time we'll have a test. Second? Did I get you? Yeah, I called you, I think so. CJ? Yeah. Whoa, maybe I didn't. I thought I did. No, I didn't. You snuck in on me, didn't you? Okay, sorry. Thanks for reminding me. All right, we'll have the test next time. Bring your formula and equation sheet. Please get your quizzes into me so you can see if you missed anything. I'm sorry? You can see it? Okay, good. Okay, all right. You want to actually see the paper? Okay. Two D's. Okay. Vienna, Shayla, J, and Z. Tequila? Yeah. I'm so sorry.
Oh, look at that. Well, look at him. All right.
Where you go?
I don't know where I just. Okay, thank you.
Good deal. Okay, I don't know. You good? All right. Good deal.